Welcome to today's deep dive. We are super glad to have you with us. Today, we've got a mission that is, frankly, specifically designed for you.
Yeah, especially if you're someone who really wants to understand the bleeding edge of AI efficiency, but you don't want to get bogged down in all that impenetrable jargon.
Exactly. Because right now, your favorite AI isn't struggling to answer your questions because it doesn't know the answer. It's struggling because it literally doesn't know which part of its brain to use.
Right? It's a huge traffic jam of information. And our mission today is to explore exactly how modern AI systems are solving that, how they're learning to direct your questions to the right expert in just milliseconds.
And the source material we are using to figure this out is just fantastic. It's an excerpt from an article called The Secret Life of Azure, the Smart Router.
Written by Aaron Rose, yeah,
Yeah.
over at the tech-reader blog.
Right, Aaron Rose. And what's so cool about this piece is the format. It's not some dry white paper. It's a narrative story. He uses this really brilliant metaphor to explain some intensely complex back-end engineering.
It's so creative. He sets the whole thing in this grand, almost imposing Victorian library in London.
Okay, let's unpack this.
Right.
Because setting a server architecture story in a Victorian library is just, it's such a vibe.
It really is. It's this place where code quality is basically the unspoken objective. Craftsmanship is everything. And we follow two engineers in this library.
Right, Margaret and Timothy.
Exactly.
Yeah.
Margaret is the senior software engineer. She's seen every tech trend come and go. And Timothy is her junior colleague.
And when we first meet Timothy, the guy is just, he's going through it, he's staring at this whiteboard, and he's just facing this brutal engineering bottleneck.
Yeah, the story describes his whiteboard as being covered in all these teal markings about quantization.
Right. But there's this massive traffic jam. He's got these four specialized, what do the texts call them? Oh, his Phi-3 students.
So it's by three students, yeah.
Yeah.
Which are essentially small, highly compressed AI models that are sitting there idle in the GPU just doing absolutely nothing.
While the entrance to the whole system is completely backed up. So wait, why is it backed up? If he has these fast students ready to go, what's the holdup?
Well, the system is hesitating. It's completely choking because it's trying to use a broadcast model.
A broadcast model means...
It's taking every single user question and broadcasting it to every single agent at the same time, basically yelling, hey, who knows how to answer this?
Oh, wow. That is, I mean, that's just absurd. It's like, okay, if I walk into a giant hardware store to buy a simple light bulb, I don't want the store manager, the plumber, and the lumberjack all running to the front door at the same time to greet me.
Right, exactly.
It's just a massive waste of energy. You only need the one guy who knows where the light bulbs are.
What's fascinating here is how Margaret diagnoses this. She points at his whiteboard and calls this problem the coordination tax.
The coordination tax. I love that term.
It's perfect, right? She tells him that having these brilliant quantized specialists is completely useless if you don't have a navigator.
A navigator at the front door.
Yes. The shift they need to make, the shift the whole industry is making, is moving away from that broadcast model and towards what she calls precision switching.
Precision switching. Okay, but how does that actually work? Like, how do you know who gets the book before they even open it?
Well, Margaret takes this bright orange marker in the story, and she just draws a high-speed switch right at the library gate.
Right, right. She calls it a semantic router.
The semantic router, yeah.
Which naturally leads to Timothy's question, which is exactly my question. Wait, how does this router know what the user wants without actually reading the whole book or the whole question?
That is the genius of it. Margaret's answer is that it doesn't read. It feels the shape of the question.
It feels the shape. That sounds so poetic for server engineering.
It does. But it's describing latent space. Think of latent space as this giant 3D cloud of points. And in this cloud, similar ideas group together into these colored clusters.
Okay, so like a galaxy of concepts.
Exactly. And the mechanism doing the work here is called an embedding model. It's this tiny, lightning-fast AI that doesn't generate text. It just converts the user's text into mathematical coordinates in that 3D space.
Oh, so it turns my English sentence into math?
Yes. So if the math of your question lands inside a cluster dedicated to, say, translation, the switch just flips automatically.
And it sends it straight to the translation student.
Precisely. And it happens fast.
Yeah, Aaron Rose mentions the speed in the text, and it's mind-boggling. This whole coordinate mapping happens in less than 10 milliseconds.
10 milliseconds.
That is insane. A large AI model couldn't even generate its first syllable in 10 milliseconds.
Right, because calculating that vector math is computationally super cheap.
Yeah.
It's just geometry.
Okay, but here's where it gets really interesting. Because, life isn't perfectly categorized. We don't ask perfectly mathematical questions.
We really don't. Humans are messy.
Extremely messy. So what happens when a query is, like, half research and half translation? What if it lands right on the border between two of those colored clusters?
That's where the router has to act as a gatekeeper. And it does this using something called zero-shot classification.
Zero-shot classification. Let's break that down because it sounds intense.
It does, but it's actually really elegant.
Yeah.
Normally, you have to train an AI on thousands of examples, thousands of shots for it to learn a task.
Right, like showing it 10,000 pictures of cats.
Exactly.
Yeah.
But with zero-shot classification, the router doesn't need to be trained on every single possible question in the universe. It operates with 0 previous examples of that specific query.
So how does it know what to do?
It uses a cheat sheet. The engineers give the router descriptions of what each specialist is good at. So it runs a really high-speed logical check. It asks, mathematically, is this new question closer to the definition of history or closer to the definition of language?
Oh, wow. So it's just checking the distance to those cheat sheet definitions.
Exactly. And if there's a true overlap, like your half research, half translation example, the router acts like a traffic controller with a PhD. It can actually split the task.
Wait, really? It chops the question in half?
Yeah. It sends the research half to the researcher model, gets the answer, and then pipes that answer over to the translator model.
That is wild. And for you listening, this is exactly why this matters. If you've ever used an AI tool and thought, wow, it handled that complex, multi-layered question so fast without freezing up, this is why.
Right. It's not getting confused by hybrid questions anymore.
It's not one giant brain stressing out. It's a team. So, okay, this system sounds perfect, almost too perfect. And Timothy actually brings this up. He asks Margaret the ultimate engineer's question. What if the router gets it wrong?
You always have to plan for failure.
Always. So what is the fallback here?
Margaret answers by taking her marker and drawing an upward arrow on the whiteboard. And it points straight to something called the lead planner.
The lead planner. So we're moving up the chain of command.
Exactly. This is the core concept of escalation logic. See, if the smart router maps your question in that latent space, but it can't find a high confidence match in any of those clusters.
Like it's just floating out in the middle of nowhere.
Right. It refuses to just guess. Because if it guesses and sends it to the wrong tiny specialist, you get a hallucination. So instead, it escalates the query up the chain to the lead planner, which is the massive, giant frontier model.
Okay, I love this. It's basically like a law firm.
Oh, that's a great way to look at it.
Right, because you don't pay the $1,000 an hour senior partner to review, like, standard parking paperwork. You let the junior associates, the small 5-3 students, handle 90% of the daily repetitive tasks.
Yes.
And the senior genius partner only wakes up and comes out of their office when a truly unprecedented, wildly complex case lands on the desk.
That analogy is spot on. And it's exactly how these massive tech companies are operating right now to preserve their most expensive compute power.
Yeah.
Running a massive AI costs an absolute fortune in electricity and server space. They only want to use it for the hardest problems.
So this semantic router is saving them millions.
Absolutely.
Which brings us to the final result in the text. It's this great scene where Timothy is watching the dashboard as they turn the system on, and the smart router icon just flickers in orange.
And instantly, 90% of all that backed up traffic is shunted directly to those slim, quantized specialists.
Boom! Latency drops to near zero, the traffic jam is gone, and that giant lead planner just stays in a deep sleep until a real mystery shows up.
It's such a satisfying resolution to that bottleneck.
It really is. And I want to pull out Margaret's closing quote here because she caps her orange marker and tells Timothy, efficiency isn't just about how fast you think, it's about knowing who needs to think.
That line really sticks with you.
It does. So what does this all mean for you, the user? Well, when you experience an AI tool today that feels magically fluid, incredibly organized, and lightning fast, it is not because the AI suddenly learned how to read your mind.
No, not at all.
It's because a semantic router mathematically mapped your intent in 10 milliseconds. It's an illusion of a single superbrain created by perfect traffic control.
But, there's a final lingering thought here that I think we really need to mull over.
Oh. Where are we going with this?
Well, we've just spent all this time learning how AI uses latent space and embedding models to perfectly route tasks to the right artificial specialist, right?
Yet.
But as these classification models become absolutely flawless at understanding the exact shape of a complex problem, how long until human organizations start using these exact same smart routers to automatically categorize, split, and assign the daily tasks of human workers?
Oh, man, wow.
Think about it. If an AI can perfectly route a digital query to the right server in 10 milliseconds based on a cheat sheet of skills,
Hmm.
it can eventually perfectly route our jobs to us.
That is both fascinating and slightly terrifying. An algorithmic manager that just feels the shape of an incoming client email and instantly drops it onto the desk of the one human employee perfectly mathematically suited to solve it.
Exactly. It's the exact same tech, just applied to human latency.
Well, that is definitely something to chew on next time your boss assigns you a project. Was it them or was it the semantic router? Such a great deep dive today. Thank you so much for exploring this with me, and thank you all for listening. We will catch you on the next one.